Calculus applications. That's normally when you get a scenario of something like volumes and surface area and we want the maximum volume surface area. That's very often the question. Questions like this is nice because then they give you the formula. You don't know how they got to that because this is a story about a cricket moving along an embankment next to the roadside and somebody's watching it, look, going up and down in obviously a cubic formation. Because if you time it out, just that first timing out is going to give you negative 2t to the 3, which means it's going to go that away, according to that. And now they also did say, and I remember, you're on a graph, so you can't go back in time, so t's got to be 1 minute, 2 minutes, 3 minutes. You can't go back, so when you're sketching it on a graph, you're a little bit restricted. Are you with me? So, the first thing that they ask me is, if they tell you that the formula is giving you the height in centimeters above the ground, and it takes them how many minutes ever. So if it's for 1 minute or 2 minutes or whatever, you'll get the height. First question is, what was the height of the cricket above the ground when it started crawling? So that's when your T is 0. Which means go for everyone there and put in a 0. And you don't have to even show me that. If you could just do that on your own and get me an answer of what?
36
centimeters.
Centimeters, not squared, because it's height in centimeters. If you just said 36, happy, most probably 2 marks. One for knowing that you must substitute T with 0, because this experiment is starting, and then one for the answer, that's 36 centimeters above the ground. And it's also good to put yourself in this scenario, in this situation, knowing what's going on here, that you're talking about a cricket, that if you get 73 kilometers, something's not lekker. Are you with me? It's got to go according to logic as well. Next one, time to get to the
maximum height.
So the moment I ask you for maximum height, you got to take height, which was f, and differentiate and put it equal to
0.
That's the facts. Because even if it was a normal graph with x's, it would have been a cubic graph. So this is still going to be cubic. And when you differentiate, you're going to get to the maximum or the minimum. You don't have to worry about maximum and minimum. You don't have to worry about science and working out all sorts of stuff. You just do your work. Can I differentiate?
No.
You can't unless you go to the top and first time it out, which is going to give you
Negative 2t3
if you write it here, negative 2t to the power 3
plus 15t squared.
Is that the whole answer? 15t squared, okay?
Minus 24t.
Minus?
24t plus 36.
Now, if you had timed it out from the start, it would have been easy to substitute t with a 0 and get to 36 like we did here. But you didn't have to. But you cannot differentiate unless it's all timed out and all separate terms. Okay, so we did skip a step there, because you should have had like 1, 2, 3 and another 1, 2, 3 if you timed it out distributively. And then you're adding them together. So we're just missing a step there. Let's do the differentiation. It's going to give you minus 60 to the
squared
okay,
plus 30t minus 24
and equal to
0.
Why equal to 0? You don't just put the derivative equal to 0. It's equal to 0 because it's when I'm working with maximum. Otherwise, derivative is also the gradient, which is alternating from one point to another. Okay, so if I want to get t, I've got to factorize. It's an equation. Please don't just put it in your calculator and give you the two answers. What are the two answers, please?
1 and negative 4.
Which will be non-applicable, right? Because we can't go back in time.
Oh, crazy.
Are you with me?
Yes, ma'am.
But if you did this, crooking it right because you use the fancy calculator, you're gonna get penalized. This is true. But they're saying, how do you get from there to there? You never showed me anything. You cannot just show this. That's why I said to you, please go make sure that you're still doing the work that you should be doing. What happened from there to there? Everything was divided by negative 6. Can I divide by negative 6? Can I do it there? No, that was the equation for finding the height. Then that minus means something, the 2 means something. But here when I'm back in an equation solving for t, I can now divide by negative 6. And if I divide by negative 6, I'm going to get plus t squared minus 5t. Divide by negative 6, it's going to give me plus 6, and it's going to, 6 times 6 is 24, guys, sorry. Divide by negative 6, so that now they are happy with my factorization. So if you use a fancy calculator to do your factorization, it's fantastic. But you've got to give them what they want. You left out that step, they're going to penalize you. Okay, so what does this mean now for my cricket? That the time it took to get to a maximum would be 1. Let's think about this. Why was there a negative 6? Now, you don't have to think so hard on it. The answer's there and it's done and I'm happy and we carry on. But think about it. We said that it's a negative graph, so it should go down, up, down again. So this should be the minimum. If I look at a graph where t is lesser, that would be at t equal to negative 4. And there would be at t equal to 1. Are you with me? Going on a graph. Not with x now, but with time. Going ahead. So for that one, it makes no sense. So what happened to this graph? It disappeared. No, maybe it just came from here. Are you with me?
Yes,
because
ma'am.
time is 1 here. So it just had to start round about there by 0 at 36. So actually the graph shouldn't have been there. And that's why your maximum would only be at 1. Don't overthink it. You don't have time for this. This is almost the last question. Just after this one comes probability. So you don't have lots of time to sit there and think on it, ponder on it. So the answer is, after 1 minute, he starts at 36, he's going to go up and get to a maximum height, and then he's going to start going down. So what about all of this? Well, that's not the road he's taken, because that was back in time. So you've got to apply it to the practical and the logical and the real life science. So we've got that t is 1. Time to get to the maximum was 1 minute. You don't have to write the minute, you're not going to get a mark loss if you don't write the minute. But what is the maximum height then? So I'm guessing it should be larger than 36, doesn't it? Because it started at 36, is going upwards. So let's see. What must you do then to find that maximum? Substitute your t with 1. In where? Can I go back to the original?
No.
Can I go back to that one? They're the same thing. You can go back to the original and say it's 1 minus 6 and minus 2, 1 squared and 1 there. And please give me an answer. Come guys.
20.
It doesn't say 20.
It's 25.
25.
Okay, but then something's not like it yet.
Why?
Okay, it's not ideal if you make a mistake, but if you make a mistake, logic must tell you something's not lacquer. Why was something not lacquer for me? Because we knew that we started off at 36. Now I'm saying that the maximum is 25. What's wrong? Okay, are you with me, guys? It's okay if you make a mistake, but realize you're making a mistake. Don't just leave stuff. Where was the mistake? It was at the factorization. This should have been minus, so that you can get back to a plus. So this answer should have been 1 or 4. Okay. So now it makes a little bit more sense. Can both of them be true? I'm going to do my little summary again. If I said that it's negative, let's go back to that one, then this should have been at 1. It would have had a at 1 it would have had a
Pounds.
minimum. And at 4, it would have had a maximum. Because now remember, my scenario has changed now. I said 1 and -4, so -4 is up, going back in time. But if time is 1 and 4, I have to realize which one is which. So I have to know that because it's a negative graph, it's first going to be at the minimum and then it's going to be at the maximum. And the maximum will be when t is 4. So this is the one for maximum and this is the one for minimum. So you had to check it out yourself. And that's why 1 didn't work, because that would have been less than where you started from, which is 25. So we know what the minimum would be. Are you with me?
Yes.
So now let's make it right. So that if we substitute with 4, we get an answer of 52. 52, that's much better. Now it's not good to make mistakes, but sometimes you learn from your mistakes. What did you learn here? That people can make mistakes, that's one thing, all the time we make mistakes. But if you make a mistake, how do you know you made a mistake? Because everything looked mathematically right. Why did we know we had made a mistake? Because the logic wasn't there. Okay, that's it. Maximum height above the ground. Still on applications. Now I'm also giving you a formula, guys. This is always better if I give you the formula. When I give you homework today, I'm going to give you one that you've got to go get the formula yourself. So that makes it more difficult. So if I give you the formula, just read what the question is. Is it a maximum height? Is it a maximum distance? Is it a maximum whatever you're trying to do, volume, area, whatever? This one said S is the depth that I take a stone and let it drop from a cliff into a swamp, I think it was. So to find how far it fell, what does this look like though to me, graph-wise? What type of a graph is this?
Parabola.
You agree?
Yes, ma'am.
And again, now it doesn't have to be a full parabola. The time can be in the negatives, then I'm going to cut it off there. Okay? So this is the distance, or the depth, sorry, that my stone is falling per second. The question is, what is the speed? Calculus.
Velocity.
What is the velocity, the speed? What must I do? First derivative. Now, personally, you know that I don't like that lot. I like to write S with a bracket T, and then here also with a bracket T, but there's nothing wrong with it. It's fine, they do it that way. And the distance of the velocity then would be 40 minus 10, and that's it. The question was, find me the speed or the velocity after t seconds. That's it. That is the speed at any amount of seconds. If I know t is 1, if I know t is 2, if I know t is 3, I'll know what the speed is. Are you with me? Find the speed of the stone after t seconds, and that's it. Find me the distance that it fell after 4 seconds. So I'm dropping the stone and it's falling. So after 4 seconds, it has to have gone a while. So I'm looking for the distance or depth. If I substitute that t with the 4, do you see why I like writing the 4 there? You don't have to, but you're going to have to take the distance formula or the depth formula and substitute in there and get an answer of 80. So it's quite far because 80 meters is high. So the cliff was quite high. Are you with me? Just get yourself in the picture there. And that's it. Substituting into distance, not into speed. Time to get to a maximum depth. What are you reading? So you've got to do derivative.
0.
We've already done the derivative, so you don't have to do it again, right?
Yes.
And then we're solving.
40.
And t is equal to?
Oh, makes sense.
Okay, are you with me here?
Yes, ma'am.
That would also be the maximum depth that it would go. And the maximum depth is 80. So it's dropping and falling into the swamp. And that's the maximum depth that it would go. Okay? So 40. Time to get to the maximum depth. And then they say, what is the time? Because they're not asking me for the maximum depth. If they did, I would say I've already done it. Because I found out what it was at 4. And this tells me at 4 it's going to be the maximum. Right? But now this question says, what is the time it took for the stone to reach a speed? Because here it falls and it's going faster, 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 faster. For the speed to reach 20 meters per second. So what is 20 meters per second?
The velocity.
The derivative is equal to 20, not 0. The derivative is 0 when you're looking at maximums and turning points, but now I'm looking at the actual speed, and the speed is 20. Let's not get technical about science, physical science, and the way that you write it. I know that you write it differently in physical science, but you know kilometers per hour, meters per second, meters per second. Are you with me?
Yes,
So it
ma'am.
doesn't matter how you write that, nobody's ever going to look at that. So what is the speed then after 20? So speed is my formula for speed, and I'll have to find out what is. Oh no, that's wrong.
Why?
No, it's not wrong, sorry. I thought I looked at the wrong one. I thought I looked at this one for depth. This is your speed, and it's the speed that you're putting equal to 20. Please can you help me? So T is? So what does that tell me?
It's 2.
What is 2?
It's
You're done with your sum, go on to the next one. What does it tell me?
time.
It took 2 seconds to get to a speed of
20
20 meters per second. Are you with me? You know what you're doing. So still number 5 to do. And then on another page, on another exercise, or a revision exercise, question 3 on page 244, it says, if I give you a prism, and I'm telling you what the volume is, find me the area of the base if they told me that the height is 5 minus
X.
x. So I know that 5 minus x, normally for volume, it's area of the base,
So it's the height.
5 minus x, times with the area of the base. So it's length times breadth times height. Are you with me? But then what do I need to do to get the area of the base? Interesting little question here. What do I do to get there?
Once you get X,
Factorizing. What type of factorizing? Batman.
crazy.
Synthetic division. You got to get that one, and that's the one part of the question. When you've got it, they say, please find the maximum volume. So if you didn't know what to do now, if I ask you for maximum volume, could you have done it from the start? I'm giving you the equation. Are you with me? Interesting little one. Then also number 10 is about a parabola and a distance that you've got to go get somewhere, and you're going to get the minimum and maximum distances of that. Minimum and maximums. That's where we apply. Guys, this is the higher level sums right at